So good morning everyone. Our next topic is phasor diagrams and different AC circuits. So what are phasor diagrams? Phasor diagrams. Phasors are the rotating vectors. So these are the rotating vectors which tell us about the angle between the potential difference, alternating potential and the alternating current. Because we know the potential as well as the current in a circuit are varying. In a AC circuit, potential as well as current are varying. So suppose this is the potential V. So when angle is 0, omega t angle, when angle is 0, then potential is 0, then it is maximum is equal to V naught, maximum potential V naught at suppose at angle pi by 2, then it is again 0 at pi. So at 2 pi it is again 0. So at 3 pi by 2 it is the negative value, it is negative minus I naught, minus V naught. This is the potential. Now because the potential is varying, similarly the current in the circuit is also varying, and if the current in the circuit and potential both are in same phase, that is V is equal to V naught, the maximum value into sin omega t, and I is equal to I naught sin omega t. So the angle is same, both are at same angle, means both are in same phase. It means the current is also varying at the same rate. Current is 0 when potential is 0, current is maximum when the potential is maximum, again current is 0 when the potential is 0, again the current is maximum when the potential is maximum. So when the current, this is the blue line is for the current I, blue line is for current I. So both the current and the potential reaches the maximum and the minimum value at the same time. It means the potential and current are in same phase. Therefore, the phasor diagrams will be like this. This is current and this will be the potential. Both are in the same phase. These are two vectors and both are in the same direction and they are rotating vectors. They are rotating means the value is changing. Suppose initially they are at angle, they are at a phase of omega t. So they are changing means it is they are reaching the maximum value and the minimum value. So at a particular angle is equal to omega t, they have a certain value. Suppose at omega t is equal to 0, they will be in the this direction. At omega t is equal to 90, they will be in the upward direction along the y axis. Now we will do the phasor diagram for different type of AC circuits. There are different types of around 4 to 5. There are 4 to 5 alternating circuits which we are going to discuss. So our very first circuit is we'll make phasor diagram for each and every circuit. So our very first circuit is the resistance only circuit. First is resistance only circuit. So in the resistance only circuit we have a source of AC current and we have a resistance R. We have a AC source and we have a resistance R. So let the alternating potential be V is equal to V naught sin omega t. So we have V is equal to V naught sin omega t. Then we have, now we the first step is we know V is V naught sin omega t because this is the alternating potential. Now we have to find the, to make a phasor diagram we must know the phase angle between the potential difference and the current. So this is the potential. Now we want to know about current. So current, we know the relation for a resistance. We know V is equal to I into R for a resistance. So V by R is equal to I. So V by R is V naught upon R sin omega t is equal to I. So let V naught by R be equal to I naught sin omega t is equal to I is equal to I naught sin omega t, V is equal to V naught sin omega t. It means this is the angle omega t and this is same. So angle between the Angle between the potential and the current is same for the resistance only circuit. So its phasor diagram will be both are in the same direction. So this is current and this is potential, both are in the same direction at the same phase. Second, we'll study about the inductance only circuit. So here both are current and potential are reaching the maximum value at the same time. So this is, if this is potential and this is the current, if this is the potential and this is current, both will reach their maximum and minimum value at the same time. Both will reach the maximum and minimum value at the peaks are at same point and the minimum value are also at the same time. Now we have inductance only circuit. Second is inductance only circuit. So in inductance only circuit we have we have a alternating source of V is equal to V naught sin omega t, and we have a alternating, we don't have a resistance here, it is inductance only, we only have a inductance coil. So we only have a inductance coil. What happens in inductance coil? So as the current moves in the circuit, as the alternating current moves, the flux changes and there is a potential difference. There is a back voltage VL. There is a back voltage along across the inductor, and that back voltage is given as, we know we know EMF induced is minus L di by dt. Minus L di by dt is the VL is minus L di by dt, and this is opposing the voltage. By Lenz's law, the EMF induced opposes the cause that produces it. The cause is the V naught sin omega t, so it is opposing it. So we can say V naught sin omega t, V naught sin omega t is equal to L di by dt, because it is opposing it. Why we are adding this relation? We know V is equal to V naught sin omega t. Why this relation? To find the relation between the potential and the current to make the phasor diagram. So from here we can find V naught is equal to sin omega t, V naught by L sin omega t into dt is equal to di. So this is small current di, which is equal to V naught upon L sin omega t dt. So from here we will find the value of the current. So current is integration of di, which is V naught by L into integration of sin omega t dt is equal to I. So integration of sin omega L is equal to sin omega t minus cos omega t divided by omega is the integration. So here we get I is equal to V naught by omega L into minus cos omega t. So the same expression, this expression can be written as V naught by omega L, and minus cos omega t can be written as sin omega t minus 90 or minus pi by 2. Why? Because sin, first of all, sin 90 minus theta is cos theta, so it is cos theta, which is equal to sin 90 minus theta, but because there is a minus sign here outside, so what is this? This is not sin 90 minus theta, this is sin theta minus 90. Why? Because we have taken this negative sign inside. So because we know sin minus theta is equal to minus sin theta. So from here minus will come out, it will get minus V naught by omega L sin 90 minus theta, which is equal to cos theta. So this will be written as I is equal to V naught by VL can be written as I naught. So this is I naught into sine omega t minus pi by 2. So what is the relation between the potential and the current? V is equal to V naught sine omega t. So it means current is lagging behind the potential by an angle of minus pi by 2. So what does it means? Current is lagging behind by angle minus pi by 2. It means when the, suppose this is the potential, this is the graph of the for the potential, and when the potential is 0, when the potential V is 0, because the current lags behind by 90, so at that time the current is not 0 but it lags behind, so it is having its maximum value, so this will be the graph for the current, when the potential is 0, current is having the maximum value, and when the current is having the maximum value, the value of potential is 0, so current is lags behind by 90 degree, so its phasor diagram will be, because the current is lagging behind by 90 degree, so we'll make its diagram like this is the V naught. So if this is V naught, so it lags behind by 90, so this is angle 90, and this is, what is this? This is I. This is I naught. I naught is lagging behind by 90, and what is the angle between potential and the x-axis? It is omega t. So this is the inductance only circuit. So one more thing we can do here. We have the inductive reactance here. What is the inductive reactance? So as we know, here we have I is equal to V naught by L omega or omega L sine omega t minus pi by 2. So this we have written as I naught. So I naught is equal to V naught by omega L, but I is equal to V by R. I is V by R, but R is the resistance. But in this circuit we don't have any resistance, we only have an inductor. Because we only have an inductor, we don't have a resistance. So this term omega L, we call this as inductive reactance. This is not resistance, this is the reactance. Reactance is similar to resistance. It is also the obstruction to the path of the current, but this is not a resistance, this is a inductive reactance. We call it as XL. Inductive reactance is XL, which is equal to omega L. And frequency, its relation with frequency is L axis, omega is equal to 2 pi into frequency into L. It means XL is directly proportional to the frequency. It means more the frequency of the alternating current, like in houses we are getting 220 volt. So 220 volt is coming, and there is a certain frequency of the alternating current. So that frequency is directly proportional to the inductive reactance. More the frequency, more will be the inductive reactance, or more will be the, so this is inductive reactance and frequency, or more will be the resistance. So if there is a current of very high frequency, if the frequency of source is very high, then the current cannot pass through the inductor. Then current will not pass through the inductor, because the At very high frequency, inductive reactance or resistance of the inductor will approach infinity. It means the circuit will correspond to a open circuit. If frequency is very high, for a very high frequency, the inductor acts as a open circuit for a current of very high frequency. Very high frequency current will not go, and low frequency current or DC current will easily low frequency current will easily pass through the inductor. So next we have capacitance only circuit. We have the capacitance only circuit. So for a capacitance only circuit, there is only a capacitor in the given circuit, and there is no resistance in the circuit. Only a capacitor is there in the circuit. So we have capacitance only circuit. Second is capacitance. Third, capacitance only circuit. Circuit having only capacitance. So for a capacitance only circuit, we have, this is the V is equal to V naught sin omega t. So here we have only a capacitor C. We have only a capacitor C. So we have V is equal to V naught sin omega t. And what is the relation between V is equal to V naught sin omega t? What is the relation between current and potential for a capacitor? In capacitor we have capacitance is equal to Q by V. Charge stored per unit potential is the capacitance. So V is equal to Q divided by C. Q by C is the potential. So therefore, and I is equal to dQ by dt. I is equal to dQ by dt. So we'll have Q is equal to CV is equal to C into V naught sin omega t. Therefore, dQ by dt is equal to current is equal to d by dt of C V naught sin omega. What is this? This is the current, and current from here after differentiating we will get I is equal to C into V naught. Differentiation of sin omega t is cos omega t, and omega will come out. So V naught omega and cos omega t. So this is the current I. So I is equal to, all this can be written as I is equal to V naught and divided by 1 by omega c, divided by 1 by omega c, and into cos omega t we can write sin 90 minus so we can write sin omega t plus pi by 2 plus pi by 2. So sin 90 minus theta is cos theta. So sin omega t plus 90 is cos omega t. Therefore the current is the voltage lags behind the current by 90 degree. So the current is leading and the voltage is lagging behind. It means here we have, this is the suppose if this is the voltage, so the current is, when the voltage is 0, the current is maximum. When V is 0, current is maximum. So the current is leading current is leading. So it is leading behind, current is leading by 90 degree. So current is maximum when the potential is 0. So its phasor diagram will be, so to draw its phasor diagram, it will be, this will be the V naught, if this is V naught, this is angle omega t. So current is V naught lags behind, so current is in forward direction by angle of 90. Current leads by 90 degree. So here also we have capacitive reactance, because there is no resistance, there is only capacitive reactance. Similarly, because we have written here I is equal to V naught divided by 1 by omega c into sine omega t plus 90. So this term is I naught. So I is equal to I naught sine omega t plus 90. So I naught is V naught upon 1 by omega c. Therefore, because I is equal to V by R, so 1 by omega c is the capacitive reactance. 1 by omega c. What is 1 by omega c? 1 by omega c is the capacitive reactance of the circuit. So here also we can find the relation between the frequency. So xc is equal to 1 by omega c is equal to 2 pi into frequency into c, or x pi is inversely proportional to frequency. So more the frequency, less will be the resistance. More the frequency, less will be the resistance. of frequency and reactance, capacitive reactance and frequency are inversely proportional to each other. Therefore, that is why a capacitor will block DC, because for a DC frequency is 0, and when the frequency is 0, resistance is infinity. Frequency is 0, resistance or capacitive reactance is infinity. Therefore, alternate direct current cannot pass through the cannot pass through the capacitor. But for but a frequency of very high current of very high frequency, the inductive reactance, capacitive reactance is very less, that current can easily pass through the circuit. Next circuit we have L and R circuit. LR circuit means the circuit containing inductor and resistance, L and R. So all have to note down all these notes in their copies. So next is LR. LR means inductor and capacitor in series. So again V is equal to V naught sine omega t is our source, and then we have a induction coil L, and then we have a resistance R. So let the potential across the inductor is VL and potential drop across the resistance is VR. Potential drop across the resistance is, we have VR as we have studied, because as we have studied that VR is in the VR and the current are in the same direction. So let this be the direction of the current, and this same will be the direction of the resistance. Inductive same will be the direction of the potential of the resistor, because if for on resistance only, resistance, potential and current are in the same phase, and for a inductor, capacitor, for a inductor, current and potential are, potential is leading it by 90 or current lags by 90. So this will be the direction of the potential for the inductor. Potential across the conductor is VL and potential across resistance is VR, and both will be at right angle to each other. Both will be at an angle 90 with respect to each other, and this will be our resistance. This will be our resultant V. What is the V? V is the resultant potential of this circuit. So this is along VL, this is along VR. So VL, VR, and this is the V. What is V? V is the vector sum of VR and VL. Vector addition of VL and VR, because by parallelogram law also we can see these are the two sides of a parallelogram, and this is the diagonal. So diagonal will be the resultant. So V is the resultant, and V is equal to, we have V squared is equal to VR squared plus VL squared. VR squared by VL squared. So because total formula is V is equal to square root of a square plus b square plus 2ab cos theta. But because the angle between a and b is, if this is a, this is b, the angle between them is 90 and cos 90 is 0. Therefore, the resultant formula is v square is equal to vr square plus vl square. So this we are doing by the vector additions. Therefore, we get and current we have to find. What is the current? Current is equal to, so vr square is equal to, v is equal to ir, so ir squared plus vl is equal to I into xl. I into xl, because v is equal to ir for resistance and v is equal to I into inductive reactance for a inductor. So it is equal to I square common r square plus xl square. R square plus xl square. So v square is equal to I square into r square plus xl square. So what is this term? This whole term is the reactance. This whole term is the reactance. For reactance in this case will be, we call this as impedance. Impedance in this case is z is equal to under root r square plus xl squared. Because what is this v square? So v is equal to ir. So v is equal to, taking the square root both sides, this will be v, this will be I, and this will be square root of r square plus xl square. So this will be the impedance, or the impedance will be r square plus xl squared. This is the total resultant resistance of the circuit. And then we have to find the angle phi. So angle phi, which is the angle between resultant, tan phi, which is the angle between the resultant and one vector vr. Suppose we want to find the resultant of a and b. So this is a, this is b, this is a, and this is the angle between them theta, and we have tan theta. What is tan theta? Is equal to, we have b sin theta upon a plus b cos theta. This is the so here also tan phi will be VL, and VL sin theta, sin of theta divided by VR plus VL cos of theta. Now we know theta is 90 because the angle between A and B is 90. Sin 90 is 1 and sin cos 90 is 0. So we'll get tan phi is VL upon VR. Tan phi is VL upon VR. And what is VL? VL is equal to IR, or I into omega L and I into R. So this can be written as omega L upon R. Omega L upon R. Because VL is I into omega L, I naught into omega L. This is I naught into R. So I'll get cancel, and omega L by R is the angle between the between one vector, one potential, and the resultant of the two potentials. This is our rotating vector for the LR circuit. Next is our CR circuit, capacitance, and now at place of inductor there will be a capacitor in series with the resistance R. So next is CR circuit. CR circuit. So this is the AC source, V is equal to V naught sin omega t, and then we have a capacitor, and we have a capacitor and resistance in series. So this is, again this will be VC and this will be VR. Again we'll make the diagram. So in this case this is the current, and VR and current are in same direction, in same phase for resistance, but VC is it VC lags behind the current. For a resistor, VC lags behind the current by 90. So VC lags behind current, so this will be 90. This will be the VC. This will be VC, this will be VR. VC lags behind current by 90, which we have done in the capacitance only circuit. So let this angle be, this will be our resultant, and this will be angle phi. Similarly, we will go as we have done in the previous. LR similarly is here, V square is equal to VR squared plus VC squared. VR squared is VC squared plus this is V. So resultant is VR squared plus VC squared, the vector sum of the both. So similarly we will write VC is equal to I square into so this is I square into R square plus this is I square upon 1 by omega L squared, because R is 1 by omega L or XC. So from here we will get in Z is V square is equal to I square into R square plus 1 by omega L squared. So V is equal to I into square root of R square plus 1 by omega L squared. So from here we get impedances that this is V is equal to I into R. So this will be the total impedance Z. This will be the total impedance Z, which will be under root Z will be under root R square plus 1 by omega L square. Z will be under root of R square minus 1 by plus 1 by omega C squared. 1 by this is omega C, 1 by omega C. So 1 by omega C squared. This will be the impedance, and similarly angle tan phi. So similarly what will be tan phi? So this tan phi again it will be the angle which we have done previously, V sin theta upon, so it will be VC sin theta will be 90 is 1 and VR into VC cos theta means constancy, it is 0. So tan phi is VC upon VR, and what is VC? 1 by omega C. VC is equal to 1 by I upon omega C, and VR is I into R. So we will get this is X C, I into XC upon I into R. So we get XC upon R. What is XC? Capacitor reactance upon R will be the tangent of phi or the angle between one vector and the resultant. Next is circuit containing L and C. This is C and R. Next is L and C. Circuit containing resistance and capacitor, inductor and capacitor. So similarly we will do as we are going. So again this is V is equal to V naught sin omega t. This is inductor and other is capacitor. Inductor and capacitor. So we'll have here it is potential across inductor is VL, potential across capacitor is VC. So the phasor diagram is, let this be the current. So we know VL is leading the current by 90, so this will be VL, and VC is lagging behind by 90, so this will be VC. So VL and VC they are opposite to each other, they are parallel and opposite to each other. So the resultant will be resultant is VL minus VC. Why VL minus VC? Because they are directly opposite to each other. So when the vector are directly opposite to each other, they can be simply subtracted from each other. This will be their resultant, and what will be the impedance? The impedance will also be XL minus XC. Now, because impedance is XL minus XC, why? Because VL is I into, so we can write this as I into XL minus I into XC. So XL minus XC will be the impedance. Next is the resonance. Resonance means during resonance the resistance becomes zero, because if capacitive reactance becomes equal to the inductive reactance, if XL becomes equal to XC, then it will be zero. Impedance will be zero, means there will be no resistance for the path of the current. And when it is possible, when XL minus XL must be equal to XC. Now what is XL? XL is omega L, and what is XC? XC is 1 by omega C. So from here we will get the condition for the resonance. So this will become omega square is equal to 1 by LC. So from here we'll get omega is equal to 1 by square root of LC. Omega is 2 pi f. 2 pi f is equal to 1 by under root of LC. 2 pi f is 1 by under root of LC, or f is 1 by 2 pi under root of LC. This is the condition for the resonance. This is the condition for resonance. And resonance means zero impedance or to the path of the current. Now last is our LCR circuit. This is the most important LCR circuit. LCR means all the resistance, inductor and a capacitor, all the three are in series. So LCR circuit all are in series, L, C and R. So we have, similarly we have V is equal to V naught sine of omega t. Now we have here, first is L, then is capacitance, and then is a resistance R. All are in series. So L, C and R. Now what is the L here? L is potential difference here. VL is the potential across the inductor, then VC is the potential across the capacitors, and VR is the potential across the resistance. Now again we will make the phasor diagram. So this is our phasor diagram. Suppose this is the direction of the current. For resistance only, we know the direction of the current and resistance is and potential is same. For inductor, the potential will leads by angle 90, so this is VL. So for for resistance it is VC. For capacitance it is VC. It lags behind the current by 90. So this is a phasor diagram. What we want to find? We have to find the resultant V, and resultant V will be the resultant of these three vectors. We have to find the resultant of three vectors: vector VC, vector VR and vector VL. Now to find the resultant of three vectors, what we do? So if there are three vectors A, B and C, and we want to find the resultant, then we first find the resultant of any two, and then we will find the resultant of A and B with the resultant of C. So resultant of A, B and C is equal to resultant of A and C and resultant of, so this will be the resultant of A and B and C. So A, B and C, so let the resultant of A and C be in this direction. So because both are opposite to each other, so this will be the direction of the resultant, and this will be, suppose this is A minus C. We assume that A is greater than C, so the resultant will be in the direction of A minus C, and this is B, and this will be the resultant. This will be the resultant of A minus C and B. A minus C or B. This is resultant of A minus C and B. Similarly, here also we will find the resultant. First is the resultant of VC and VL. Resultant of VC and VL is, suppose VL is more, we will get this much length is VL minus VC. So this vector is VL minus VC and this is VR. So resultant of VL minus VC and VR is our total potential in the circuit. So let this will be the resultant. This will be the resultant. This is the resultant of VL minus VC and VR. So this is V. So now we assume that there are only two vectors, VL minus VC and VR vectors. Therefore resultant is V square is again, because the angle between VL minus VC and R is again 90. So V square is equal to VR squared plus VL minus VC squared. This is the resultant. So we have V square is equal to I into, this is R squared, I square into, we are taking the I common, so I square into R square is VR square, and from here it is plus XL minus XL minus XC squared. So the R will be multiplied I into XL minus I into IC squared. So I square is common. Now V is equal to I into R. This whole is the total impedance. Total impedance. So the impedance of this circuit is square root, because this is V square, will get square root. Z is equal to square root of R square plus XL square, XL minus XC whole squared. This is the impedance of the circuit. This can also be written as Z is equal to under root of R square plus XL is omega L minus XC is 1 by omega C squared. So this is the impedance of this LCR circuit, total impedance of the LCR circuit. Now second is the tan phi, angle tan phi. What is the angle tan phi? Angle between the resultant and the current. This is the phi. So tan phi, it will again will be VL minus VC divided by VR. So this is one vector, this is second vector. So resultant where the second vector is B sin theta upon A plus B cos theta. So B sin theta means VL minus VC into sin 90 divided by VR plus VL minus VC into cos 90, which is 0. So VL minus VC upon VR is the value of tan phi. Now there is certain conditions in this. The conditions which we are going to see, conditions. First is if omega L is greater than omega C. If omega L is greater than 1 by omega C. Omega L is greater than 1 by omega C, because here it is VL. Here we can see, write it as omega L minus 1 by omega C divided by R. This is the tan phi. So because I will get cancelled, IR and I into omega L minus I into I upon omega C. So I will get cancelled, omega L minus 1 by omega C upon R. So if omega L is greater, it means this term will be positive. If omega L is greater, so tan phi or thus phi will be positive. So because tan phi will be positive means the V will be in this direction, as it is shown now. Phi is in this direction. Phi is anti-clockwise angle are positive and counter-clockwise and in the clockwise direction. If we measure this angle phi, so this will be minus phi and this is phi. Here it is positive, it means the phi is in the first quadrant, the resultant is in the first quadrant. It means V is leading the current. V is leading the current by angle phi if omega L is greater than 1 by omega C. Now if omega L is, second condition, omega L is less than 1 by omega C, then tan phi will be, because this is less and this is greater, so this will become negative. Tan phi will be, or phi will be negative. So if tan phi will be negative, so this will be the direction of the current. Potential will be in the fourth quadrant. It means potential will be lagging behind the current by angle phi. Potential lags behind current by phi. Here potential leads by angle phi. Now there is a third condition, which is the condition of the resonance. Third condition, what if omega L becomes equal to 1 by omega C? If omega L becomes equal to 1 by omega C, it means tan phi will be 0. So then tan phi will be 0 or phi will be 0. It means both the resultant and VR will be in the resultant and current will be in the same direction. So the condition will be potential and potential and current will be in the same phase. So this will be V and this will be I, both will be in the same phase when omega L is equal to 1 by omega C. Omega L is equal to 1 by omega C, or this is the condition of resonance. This is the condition of resonance, and at resonance when omega L is equal to 1 by omega C, then impedance of the circuit will be, so this is the impedance R square minus omega L minus 1 by omega C. So because this will become 0, omega L is equal to 1 by omega C, so omega L minus 1 by omega C will be 0. So Z will become square root of R square or R. Z will be equal to R. So resistance of the circuit will be minimum at resonance. Resistance will be minimum and it will be equal to R, which is the equal to the minimum resistance will be equal to resistance of the resistor. So the LCR circuit at resonance, it acts like a resistance only circuit, because impedance is also equal to R resistance and potential and current are also in the same direction, as is the case of resistance only circuit. So here all the different types of AC circuits are complete. In the next video we can continue with the next topic. So note down all these in your notebooks.